Good morning, everyone. Let's talk about conveyor and conveying systems. What are conveyor systems? Conveyor systems are mechanical devices that move materials from one place to another with minimal effort. Conveyors are especially helpful in applications involving the transport of heavy or bulky materials, create buffers, and deliver products in sequence for a production line. These systems are seen in a wide variety of industries from automotive to pharmaceuticals. The next slide will show you how conveyor system works.
Conveyors move bulk material or discrete products from one area to another and serve as main material handling arteries to improve efficiency and throughput. Advances in materials, controls, and modular subcomponents have spurred new large conveyors for bulk material transport, miniature conveyors for discrete sorting, and everything in between. During manufacture, myriad products move on conveyors, so conveyors come in an array of shapes and widths of less than 2 inches for moving extremely small parts to several feet wide. Once viewed as an afterthought, conveyors have become an integral element in nearly all automated facilities and applications. Select a conveyor first by asking, what types of product is the application moving? Conveyors for material handling of bulk product are more rugged than those for moving discrete product. In contrast, the latter requires conveyors that can advance product with more precision. How does surrounding equipment interact with the product riding on the conveyor? Conveyor Class 1 includes material handling uses in which the conveyor serves as an artery to transport bulk or discrete product in a steady stream with little interaction along the way. Class 2 includes conveyors that act as bridges to take product from one location or machine to another. Class 3 includes conveyors that take materials into or out of machines or stations. Class 4 includes conveyors that run right through machinery without break. The first two classes generally prioritize ruggedness or throughput. The last two classes need positioning and, in many cases, custom workpiece pucks to steady product while machines perform work on the product pieces. What is the maximum weight of the product being moved? Does the conveyor need to operate at a certain speed? Does the application need the conveyor system to have inclines, declines, or curves? Look for conveyor features that secure or enclose the material or product onto the conveyor. Will moisture be present in the application? Does the application need to be sanitary? Here, look for rugged or washdown rated conveyors with open frames. Most conveyors in light and medium-duty discrete transport applications use belt that's wrapped around 2 or more pulleys. A motor powers the pulleys that in turn engage the conveyor belt. Belt styles and materials abound to meet specific applications. Some belts are low friction, so product can slide a bit for accumulation. In contrast, high friction belts have more grip to better hold products. Engineers can design such conveyors to meet exact application specifications. Timing belt conveyors use tooth belts that engage synchronous drive pulleys while serving as the conveyor surface as well. These provide excellent belt movement control for accurate part or fixture positioning. Magnetic conveyors are built with ceramic magnets for applications needing parts to adhere to the belt during processing or for jobs that require elevation changes. Higher magnet strength serves inverted applications. Vacuum conveyors work with a perforated belt that draws air through grooves in the conveyor bed plate to hold light or flimsy parts on inclines or during especially fast transport. Some metal-free conveyors have polymer bed plates instead of steel bed plates where metal scanning equipment checks product, usually food, for contaminants. Last but not least, pivot conveyors mount to a base to swing away when workers need to walk through a line. Some controls can automatically resume product flow after conveyor returns to the inline position. Where the conveyor takes the form of a timing belt conveyor, servo drives accurately stop and start the setup to provide precise part location. They also let engineers control acceleration, so work for conveyors that serve assembly lines. Encoders on a conveyor's drive shaft sense shaft rotation or count pulley revolutions for belt control in feeding or indexing. In some, though certainly not all cases, single drive, multi-belt conveyors serve 2 or more lanes of product for the sake of efficiency. Here, 2 or more conveyors run off a single gear motor on a common drive shaft or coupled shafts. Multi-belt conveyors can also serve to move very wide products and are indispensable in setups that handle work piece pallets. In some arrangements, the belts even mount to one conveyor frame. For more videos like this, visit designworldonline.com and click on videos.
Brief history of conveyor systems. The earliest conveyor. It is well known that Henry Ford did not originate them with his vehicle assembly lines in the early 20th century. He found the idea of the assembly line from another Michigan-based automobile company run by Ransom Olds. Benefits of using conveyor systems. Conveyor systems can safely transport materials from one level to another through elevated conveyors. It can be installed in most situations while usually being able to add value and increase the safety of the workplace due to the automation. Conveyors can move high quantities of items in various shapes, sizes, and weights. Like kay sa most industries, naman gyud tay mga conveyors nga makita like sa pharmaceuticals, sa automation. So dili lang gyud siya nag-focus sa kanang mga ginagmay, like pwede gyapon siya sa mga dinagko like mga nakapack na, kinarton, and many more. So also have advanced safety features that prevent accidents and injuries while increasing throughout the system. So variety of options to run the conveying systems, including the hydraulic, mechanical, and fully automated system, which are equipped to fit to individual needs. Types of conveyors. The first type is the belt. Belt conveyor is a kind of conveying machine which transport materials from one place to another place continuously. Due to conveyor systems being adaptive, they're able to use in most industries due to the variation of weight, length, and items they can carry. Also, belt conveyors are the most commonly used power conveyors because they are less expensive. The next slide will show you how belt conveyor works.
Roller conveyor. Roller conveyors are a series of rollers supported within a frame where objects can be moved either manually, by gravity, or by power. There is a wide range of ways roller conveyors can be used and modified for different uses, including transporting boxes, cardboard boxes, crates, pallets, plastic totes, poly bags, slave boards, and trays. A roller conveyor system can be configured to work with a range of ancillary equipment including bends, gates, and turntables. History of roller conveyor. In 1908, Jaime Goddard of the Logan Company in Indiana was awarded the first patent for roller conveyors. The conveyor did not become widely used until 5 years later. In 1913, Henry Ford made a milestone in history by introducing the renowned assembly line. In the 70s up to now, conveyor systems in have witnessed developments to their technologies and innovations from introducing power conveyors through to using computers to control complex applications. There are new variations to the conveyor systems to keep the industry in motion, all with the goal to reduce time and increase optimal performance. Types of roller conveyor. Gravity rollers. Gravity rollers are not powered by an external source. They use gravity to power the rollers and transport your products. They need to be on a downward path at a specific angle to ensure the flow of the rollers. Plastic rollers. Plastic rollers are a cost effective choice that doesn't sacrifice on quality. They are ideal for a range of industries as they make cleaning efficient and simple. Rubber coated rollers. Rubber coated rollers it is used if the product is delicate and prone to damage. The rubber coating gives more gentle handling. Steel and stainless steel rollers are some of the most popular options available. They are easy to clean and durable and can transport heavy duty materials. Parts of roller conveyor. Drive belt. Drive belt is a motorized belt to power each roller, allowing this conveyor type to control the motion of the materials being transported. Bed rollers, or roller bed conveyor belts, are a good option for transporting items over long distances as they reduce friction, making it easier for products to move along the belt. Drive pulley. It provides the driving force for the conveyor. In order to increase pulley life and traction, it often has a larger diameter than other pulleys. Types of conveyors. First, we have powered ruler conveyors. Powered ruler conveyors move items by mounting powered rulers in frames. The drive type, roller diameter and material, and axle center size are all important requirements. Powered roller conveyors are generally employed in material handling applications that need powered product transportation. Belts, chain sprockets, and powered rulers are examples of many drive types. Food handling, steel making, and packaging are some of the applicants for motorized roller conveyors. The another one is slat or apron conveyor. An apron conveyor is a type of conveyor made from individual apron plates that are linked together with hinges on its other side, thus creating a loop carrying surface where materials can be placed. It plays a vital part in several industries by being used to move different materials from one location to another. This type of conveyor is used to deliver a large number of materials across several phases of production and is particularly useful for transporting of huge and heavy materials. There are two types of apron conveyor. First, we have bended steel plate. Steel plates are bended as their front and back are overlapped. The plate need to be put ingeniously to prevent the stuffs from falling out even the stuffs are powdery. Second, we have steel plates connected by hinge. Front steel plate is connected to back steel plates with hinges. Both plates are connected and can move freely as well. This shape is worked out for the purpose of preventing the conveyed stuffs from falling down from apron plate. This is more expensive than bended steel plate type apron plates. How apron conveyor works. Aprons are mounted with attachments at both sides of conveyor chain and the carried objects put on the apron are conveyed as the conveyor chain moves forwards. This apron is normally made by steel plate and the carried stuffs are put on the plate and conveyed. It makes possible to convey steep slope by attaching frames to the aprons. Also, carried stuffs will not fallen out from its side edges by attaching side guards. Apron conveyors, however, are not recommended for use in the food industry since there is risk of contamination from the conveyor surface. Parts of apron conveyor. Head shaft. The head shaft assembly consists of chain drive sprockets bolted to a hub mounted to a head shaft. This assembly rotates to move the chain and flights forward. Tail wheels. The tail wheels take up assembly returns the chain and flights to the working surface of the feeder. Chain. The chain wraps around the head shaft and tail wheels and rides on carry rulers to provide movement. Carry rulers. Carrying rulers provide load carrying to the working side of the feeder. Return rulers. Return rulers support the chain or flight assembly on the return side. Drive sprockets. Drive sprockets intermesh the chain, moving it and the flights. Impact rail. Impact rails are installed under the flights in the loading and strike-off area to prevent permanent deflection of the flights. Mainframe. The mainframe provides a base for the operating components.
Hello, good day everyone. This is Earl Nakasabog Casino of BSME 4A. To continue the discussion about conveyors, we will talk about here the type of conveyors. First is the bulk transfer conveyor. A bulk transfer conveyor or table is used for applications where there is a need to reorient boxes, cartoons, totes, etc., or to manually transfer items in multiple directions. Available in straight and curved sections, with various ball centers to meet specific requirements. Also available in pneumatic table for assembly applications, where there is a need to transfer product and then lower the table height for stability of work, then raise product and transfer back onto the conveyor system. It can be manufactured with either carbon steel powder coat painted frames or stainless steel frames with a choice of either carbon steel, stainless steel, or nylon balls. How bulk transfer unit works. Bulk transfer units allow you to convey packages, assembly parts, and other materials in every direction with minimal friction. They use easy running bolts and medium heavy and heavy plates to smoothly move containers with smooth surfaces through production lines, shipping assembly areas, and other areas where speed and efficiency is required. Typically, bolt transfer units are composed of a single large bolt, usually made of steel but sometimes made of plastic or even wood, that is supported by smaller ball bearings. This allows the ball to move omnidirectionally smoothly. Examples of ball transfer conveyor. One of the most common examples of ball transfer tables are luggage delivery carousels in airport baggage claim areas, but ball transfer tables have multiple industrial, manufacturing, and warehousing applications as well. Another type of conveyor is the magnetic. Magnetic conveyors, also known as magnet conveyor, are not unlike other conveyors that they move product from one end to the other either through or on top of a reciprocating belt. It contains ceramic magnets in the bed of the standard conveyor. Magnetic conveyor hold ferrous parts fast to the belt and are ideal for elevation changes or part holding. They can be used in upside-down applications with the strength and size of magnetic field designed per application. How magnetic conveyor works. The usage of conveyor magnets which allow these conveyors to exploit the magnetic qualities of material is what sets them apart. Because the magnetic pull is strong enough to withstand gravity, these conveyors can be utilized in any orientation, including horizontal, inclined, vertical, and even upside down. Depending on the application, this strength can be adjusted, allowing both light and heavy goods to be transferred if they are magnetic in nature. When a conveyor bed is energized and timed, ferromagnetic items will be conveyed by electromagnets that are equally spaced. Types of magnetic conveyor. First is a magnetic belt conveyor. Magnetic belt conveyor are one of the most widely used types of these systems, as they are easy to both construct and operate. A belt is magnetized from below with either a large permanent magnet frame or a series of electromagnets, which causes any magnetic materials to stick to the conveyor belt. The conveyor functions identically to belt conveyors, but it has the added advantage of being able to convey its materials in almost any direction. Another type of magnetic conveyor is a beltless magnetic conveyor. A beltless magnetic conveyor, also known as a slider bed conveyors, it is not use a belt to move the material. Instead, a rotating internal chain of permanent magnets distributes magnetic force through a fixed bed. The magnets beneath the bed will attract any magnetic material, which will drag across the bed and to the discharge end when in motion. Its design allows it to be entirely submerged in material, because only the stationary bed contacts the material. The beltless design also allows for sanitary transportation. It is a wonderful alternative if your material will not be damaged by the dragging motion. They are virtually maintenance free and endure longer than other magnetic conveyor types. Next is the magnetic separators. It is a belt conveyor with specific magnet belt that is used to sort ore particles or loose mixes. The material is initially conveyed from feed point on a short belt that is magnetized by electromagnetic rollers, and then sorted according to its magnetic constituents. Unlike semi-magnetic and fully magnetic material, non-magnetic material will fall further from the belt, effectively sorting and separating the aggregates. It comes in a variety of shapes and sizes, but they all serve the same purpose, to separate magnetic products from non-magnetic combination. They are most often used in mining and chemical application where the removal of impurities is paramount to product integrity. Another type of conveyors is a bucket conveyor. Bucket conveyors use reciprocating buckets to carry items vertically. Bucket conveyors consist of endless chains or belts to which are attached buckets to convey bulk material in horizontal, inclined, and vertical paths. How bucket conveyor works. The conveyor is made of an interconnected loop of buckets that stay level when moving from horizontal to vertical, preventing their contents from spilling out. The conveyor is loaded with material at the front, or booth, and each bucket automatically deposits at the end of the run, also known as discharge. This process is a fast and automatic method of vertical conveying, as the same buckets which pick up material are used to deposit it. The design of this machine depends heavily on the material being transported as well as the desired height that it must travel, but they are reliable and efficient if made correctly. Types of bucket conveyor. First is a centrifugal bucket conveyor. Using centrifugal force, centrifugal bucket conveyors move free-flowing material. To optimize centrifugal force, evenly space buckets on a chain into the material at the inlet and then throw it out of the discharge throat, usually directly after the change stop turn. A metal enclosure surrounds these buckets, which prevents material from going anywhere other than out the discharge end, where any excess material will simply fall back down and restart the conveying operation. Next is a continuous bucket conveyor. It distinction from other bucket conveyor types in that they are meant to transport fragile or light material. They move at much slower speeds, 3 to 5 feet per second, and there is no gap between buckets to prevent any spillage. They minimize product damage by preventing aeration and handle fragile and friable products. They can come in many shapes and ratings and can be in an S, Z, or C shape depending upon need. Defined uses in plastics and mining industries, severe duty uses, and other applications that require minimal agitation. And lastly, a positive discharge conveyor. Positive discharge conveyor are a special kind of centrifugal conveyor where their buckets pass over an extra sprocket which jolts the material out of the discharge end. They move at a slower speed to 2 to 4 feet per second, which prevents undue spilling and breakage of material. The bucket design of these conveyors are unique to each manufacturer and are made larger to compensate for their slower speeds. They are most useful in applications such as the movement of cereal nuts, dried fruit, and other similar types products where the priority is to preserve product integrity.
So here is the type of conveyors. First is the chute, which is chute or throw conveyors. It is a type of material handling device that transports goods from one level to the next by using gravity to move them along smooth surfaces. The material of the chute, as well as its physical measurements, such as length and width, are important considerations. Depending on the application, chute conveyors can be used for scrap processing, packaging, postal service package, or mail handling, and so on. Chutes are built with a low coefficient of dynamic friction to allow the product or material to slide freely and can be straight or curved. Here are some uses of chute conveyor. Unit or bulk, on floor, and to accumulate. Second is it is inexpensive. Third is used to link to handling devices. Fourth, used to provide accumulation in shipping areas. Fifth is to use to convey items between floors. Six is difficult to control position of the items. Lastly, main method of transport is gravity, making a chute conveyor very inexpensive. And here is the drag chain. Drag chain conveyor. Chain conveyors are often utilized to transport coal, wood, refuse, and scrubber sludge in pulp and paper mills, waste-to-energy facilities, and coal-fired electric power plants. So how does a drag chain conveyor operate? The principal operation of a drag chain conveyor is based on material movement using a skeletal chain and flight assembly that is drawn along the bottom section of an enclosed housing. Drag conveyors are an optimum choice for bulk processors, power producers, cement manufacturers, and minerals processors for conveying efficiency and enclosed housing. Drag chains are used to guide, support, and protect a variety of constant flex cables and hoses, such as bio-oil and microbial resistant cables, because it is resistant to abrasion and biofuels. They are environmentally friendly since they are made of recyclable materials. Types of drag chain conveyor. First is the standard drag chain conveyor, or simply drag chain conveyors, uses two endless chains with evenly spaced paddles between them, which drag along the bottom of a trough to transport material. The amount of bulk moved by each paddle is dictated by its surface area, as well as the chain speed, and they are replaceable once they wear down. The chain speed is typically slow, which decreases energy consumption, and the whole assembly is easy to use, simple, and cost-effective. Second is the en masse drag conveyors. Unlike standard models, these conveyors utilize a single-stranded chain with paddles attached to both sides, sometimes referred to as skeletal chains, for their resemblance to the vertebrate. The chain runs in an over-under arrangement, where typically the bottom strand is carrying element and material is fed through the top strand. There are split-in conveyors that house both strands in their own troughs, effectively creating two conveyors moving in opposite direction. Tubular drug conveyors are similar to the second conveyor in that they are designed to handle omnidirectional inputs and outputs. This assembly is enclosed within a tubular housing and contains single-stranded drug chain with equally spaced discs that are functionally the same as flights. In addition, its design enables for a vertical, airtight conveyance which is difficult to achieve with other types of handling equipment. This conveyor type can handle fragile products that would not be suited for other types due to the gap between each disc, which prevents unwanted forces from acting on the material. So here are the parts of drag chain conveyors: the conveyor rolled ball bearing unit, the conveyor roller, drag bar, front drag plate, conveyor change, frame support, conveyor drive ball bearing unit, rear drag plate, lubrication fitting, conveyor drive sprocket gears, drive shaft, the drive sprocket wheel, the conveyor drive sprocket gear, and chain guard box. And this is the type of conveyors, which is the overhead. Overhead conveyors are unique from other conveyor types in that they operate above or over the head of both workers and other equipment. They maximize conveyance by utilizing unused overhead space, and do so via a revolving, endless loop of chain within a rigid track or a straight run of trolleys. Overhead conveyors are easily implemented into most plants as their modular design is meant to work around the complicated twists and turns of on-floor machines. They are energy efficient and use smaller amounts of power than most other conveyor types if powered at all. So, here are some specific needs of an overhead conveyor. Enclosed track versus open track overhead conveyor. Enclosed track are less susceptible to environmental decay, especially in applications such as painting where overspray can damage the chain over time. Conversely, open track conveyors are easier to install, taking a more typical I-beam form and opting for trolleys instead of a chain, and are generally simpler. Enclosed track overhead conveyors will prevent excess damage, but open track conveyors can hold more weight per carrier. So the choice is ultimately dependent on the characteristics of the conveyed items. Powered versus free overhead conveyors. Overhead conveyors can be free to move or can be powered via a motor, depending upon the needs of the project. Free overhead conveyors are moved with user pushing or pulling and are an effective economical option. Powered overhead conveyors are more often chosen, however, as they require no manual labor, can be automated and speed controlled, and are a more organized conveying method. Free overhead conveyors cost nothing to run, but the energy efficiency of a powered conveyors is quite impressive. Lastly is the synchronous versus asynchronous overhead conveyors. Synchronous overhead conveyors ensure that the system is non-accumulating, meaning that each item is equally spaced and moves at the exact same time. In synchronous movements, this arrangement is also mean that every item starts and stops together which allows operators to have command over the whole assembly process via its drive control. In contrast, asynchronous models allow for each item to move independently of others and are typically unpowered, though exceptions may exist.
Good day everyone, I am Sharia and I will be discussing about pneumatic conveyors and the types of conveyors. Pneumatic conveying is the process of transporting granular or powdered materials by floating the materials in a gas, primarily air, and allowing it to flow to the destination through a closed pipe. Pneumatic conveying system is used for transport of dry materials through pipelines to various storage or process points which are economically inaccessible by conventional conveyors. The positive or negative pressure inside a conveying line moves materials safely with little damage or loss. The operating principle common to all types of pneumatic converting is that motion is imparted to the materials by a fast-moving stream of air. Pneumatic conveyor consists of an air supply equipment, which are the blower or compressor, pipelines, storage, airlock feeders, and dust filters. The advantages and disadvantages of pneumatic conveyors. For the disadvantages, pneumatic conveyors can run long distances either horizontally or vertically. Enclosed nature blocks dust from entering into the surrounding area while ensuring that contaminants don't enter the pipeline. Operators can maintain a consistently controlled atmosphere. The conveying pipelines can be routed and rerouted with little efforts as per demand of the operations. It offers a flexible system, and it makes possible unloading of materials from ships, barges, transport vessels directly to the storage bins. And for the disadvantages, the types of materials suitable for pneumatic conveying is limited to materials which are dry, granulated, pulverized, crushed, and essentially free-flowing. Friable or too abrasive materials are not suitable to be transported by pneumatic conveyors. Product damage and line plugging can occur with wet or fragile products, seeing as wet products can plug pipelines while fragile products may not be able to withstand the high velocity airflow and sharp turns. Blowers and fans can produce a lot of noise, but this can be mitigated with sound enclosures. The blower size is often limited, which subsequently limits scalability if you want to install larger systems. The basic components of pneumatic conveyors. Pressure blower is one of the two methods for moving materials using a pneumatic conveying system. When designing a system, a major factor is the amount of pressure dropped throughout the system, which is the most extensive at the end of the system. The force of the blower determines the flow rate at cubic feet per minute, velocity in meters or feet per second, and the pressure. Pressure blower pushes the material down the pipeline. Vacuum pump is another method of moving material. Vacuum systems are often used as part of a dilute phase system, which will be discussed later on, but can also be applied to dense phase systems. An electric-driven vacuum pump is the most efficient and recommended method for producing the vacuum. Rotary airlock valves are used for handling solids when it is necessary to separate two areas under pressure while moving the material from one condition to the next. They are used at the beginning and end of a pneumatic conveying system. Conveying line contains the material and method of transport. Diverter valve prevents contamination and provides line switching. Filter receivers contain and separate dust from material in a pneumatic conveying system. The unwanted airborne material is trapped in the filter in the receiver unit. Second separator uses centrifugal force to remove particles from air in a pneumatic conveying system. Air enters the cyclone whose rapid rotation separates the particles, which are blown against the wall and fall to the bottom of the container. Batching system uses pneumatic conveying for mixing ingredients that are injected into the conveying line and forwarded into a mixture. Batching operations dramatically increase the size of a pneumatic system. Hopper contains the material before it is introduced in the conveying line. A rotary airlock valve releases the material from the hopper. Controller is a necessary part of a pneumatic conveying system and it is designed to fit the needs and configuration of the system. Common controllers are microprocessors. They are designed to control blower and filter operations, valves, receiving hopper control, loaders, and filter pulsing using a computer. Here are the types of material conveyed by pneumatic conveyor: cement, coal dust, grain, cotton, and sawdust. Main application of pneumatic conveyors are burner feeders, metal powder transporters, recycling, and any similar use case that needs the transfer of powders, granules, flakes, and dry bulk. They are flexible option for designers to move fine products as the conveying pathway can be bent around existing equipment and is relatively small. Types of pneumatic conveyors. First is the dilute phase pneumatic conveyors. Dilute phase pneumatic conveyors are a common system for non-fragile materials and implement low pressure, high velocity air streams which fluidize fine particles and low product to air ratio. Material is loaded into a hopper when an air mover then sends it through the conveying line to its destination at high speeds. The example material that they conveyed are the flour and cornstarch. For the dense phase pneumatic conveyors, they are the opposite of dilute conveyors as they utilize high pressure, low velocity to move products prone to breakage, and high product to air ratio. The material is loaded into a pressure vessel where high pressures force material into the conveying line to its destination. Dense phase conveyors are therefore much slower than dilute phase varieties but are also much easier on the material. Examples of materials they conveyed are sand, sugar, and carbon blackberry. Semi-dense phase pneumatic conveyors. They are a middle point between the last two pneumatic conveyor types and have qualities of both as a result. Semi-dense pneumatic conveyors tend to be chosen when dense or dilute conveyors do not work, as they provide some increased speed yet still protect the material through the system. A semi-dense phase conveying system is the optimum solution for medium rare transfer of friable materials. Types of conveyors. Screw, also known as spiral, worm, or auger conveyors transport goods using helical components. They are made up of helical screw elements or a steel auger that revolves around the central shaft, propelling in the work material in a direction dictated by the screw design and rotation. To fully use the rotating force, the helical screw operates within a casing, trough, or compartment. A helical conveyor efficiently transports bulk quantities of materials such as granular solids, semi-solids, liquids, and non-flowing solids. Components of the screw conveyor. Conveyor screw, couplings, hanger bearings, trough ends, traps, covers, clamps and shrouds, flange, discharge spouts, supporting feet, and saddles. Types of screw conveyors. Horizontal screw conveyors are the simplest form of screw conveyors. This configuration can handle a wide range of bulk material characteristics. They can efficiently distribute the bulk material to various locations of the screw conveyor through use of multiple inlets and discharge points. They are designed to have a trough loading of 15 to 45 degrees. Trough loading refers to the maximum depth at which the trough can be loaded to prevent undue wear and fatigue on the screw conveyor components. It depends on the characteristic of the bulk materials to be handled, and it is an important factor in screw conveying sizing. Generally, trough loading can be higher for light, free-flowing and non-abrasive materials and must be lower for viscous, heavy and abrasive materials. Inclined screw conveyors. Inclined screw conveyors offers an inclined path that eliminates the need for additional conveying equipment for transporting bulk materials to and from an elevated surface. An alternative to this type is the use of two pieces of conveying equipment, one piece of equipment for horizontal transportation and one for vertical transportation. However, this setup is expensive and consumes more space. Vertical screw conveyors transport bulk materials on vertical paths and very steep inclines with an angle of inclination greater than 45 degrees above the horizontal. They are also space and cost efficient in transporting bulk materials. Controlling the amount of bulk material fed to the screw conveyor is critical for vertical screw conveyors to maintain a constant speed, reduce wear and power consumption, and increase the conveyor efficiency. Hence, bulk metering devices such as screw feeders are necessary. In shaftless screw conveyors, the shaft of the conveyor screw and its internal bearings are not present. This eliminates the tendency of material buildup and flow obstruction. Hence, shaftless screw conveyors are ideal for conveying sticky, viscous, and sluggish materials. They ease the conveying process for these materials and generally have improved conveying efficiency. They are also used to convey products for mixers, centrifuge, and filters. Live bottom screw conveyors. They are used to meter and control the volume of the flowing bulk material drawn from hoppers, bins, and silos. They are usually installed at the bottom of these vessels. They consist of multiple tapered, variable pitch, and mass flow conveyor screws to accommodate the fluctuations in bulk material volume at the screw conveyor inlet. They can also be used as a screw feeders to another screw conveyor. Flexible screw conveyors. Flexible screw conveyors are made up of a shaftless conveyor screw and a flexible tubular shaft made from UHMW polyethylene, which are the extremely tough plastic material with high abrasion and wear resistance. Since both conveyor screw and shaft are made from flexible and bendable materials, flexible screw conveyors can transport bulk materials over a wide range of distances, angles, and elevations. These conveyors can save space as the path for the bulk materials can easily be routed and the electric motor and discharge outlet can be positioned flexibly. The conveyor screw can either have a round or flat spiral profile. The latter is typically installed for additional flexibility and strength. A flat spiral profile is used for higher feed rates.
Good day, everyone. I am Katriona Candaroma, and to continue the discussion, another type of conveyor is this vertical conveyor. So this is what a vertical conveyor looks like. So a vertical conveyors transport items vertically between conveying line levels. The lift, speed, and maximum load height are important parameters. Vertical conveyors transport goods or products to higher floors of a facility. They are further subdivided into two types, the continuous lifting and reciprocating. The first type of vertical conveyor is this continuous vertical conveyor. So the purpose of continuous vertical conveyors is to keep the material flowing through vertical parts of the supply line indefinitely. They achieve this by utilizing platforms or trays or shelves that begin from a horizontal conveyor, where these sections then mechanically travel up a vertical shaft and then dump back into another horizontal conveyor of the same type. So the picture seen in this slide is an example of a continuous vertical conveyor. The blue part on the corner part, or this platform, lifts the load vertically and then transfers it to the conveyor on the higher level, and then it moves again horizontally. So basically, continuous jud iyang movement, though galahi siya og direction. So from horizontal to vertical and then back to horizontal. Another type of vertical conveyor is the reciprocating vertical conveyor. So a reciprocating vertical conveyor, also known as reciprocating mezzanine lifts, transfer objects on a horizontal platform that can be driven or gravity activated. This platform is frequently a horizontal conveyor that may travel up and down various levels to service multiple floors. So this type of conveyor is actually gravity actuated lift. This is only designed for lifting materials and not for like the operators or for any other persons. Also, another type of conveyor is the vibrating conveyor. A vibrating conveyor transport material along their system beds using rotational or linear vibration. Vibrating conveyors are used to transport dry, bulk commodities like stone, gravel, coal, and so on. The conveyor's bed vibrates to transport the material along its length. The conveyor might take the form of a trough, a tube, or a flat tabletop. Depending on the purpose, a variety of sizes are available. So usually, this type of conveyors are extensively used where sanitation and low maintenance are required. So the function of vibrating conveyors is highly dependent upon its motor and its construction. Thus, it is hard for us to generalize the working principle of all vibrating conveyors. So another type of conveyor is the walking beam conveyor. This is what it looks like. So walking beam conveyors index workpieces across production cells by combining static and moving supports. Walking beam conveyors are utilized in automation and assembly lines where objects must be sequentially placed in particular positions. The object that is being sustained in a stationary position is picked up by the walking beam and referenced to its next point, where another production process occurs. This movement is repeated along the conveyor's length. So these conveyors are known for moving things up, forward, down, and back by engaging them from below. So in some cases, the beam is used for contacting the products from the side. So for better demonstration, here is a video of how the walking beam conveyor works. So inadto ang working principles sa walking beam conveyors. Another type of conveyor is wheel conveyor. Wheel conveyors employ gravity or physical power to convey goods along their lengths using unpowered wheels. Wheel conveyors are often used for loading and unloading vehicles, as well as transporting packages, pallets, and other items through facilities or along assembly lines. Depending on the weight, requirements, and application, the conveyors are set by the number of wheels and wheel spacing. So gravity roller skate wheel conveyors can be used for many applications. So as mentioned, they are commonly found in warehouses, in back rooms, or on docks. So if you regularly convey light products, a gravity roller skate wheel conveyor may be a good choice. So here are the applications of conveyors. First is mining industries. So in mining industries, as seen on this picture, this type of conveyor is vibrating conveyor. Next is automotive industries. So it is clearly seen in this picture that they are using overhead conveyors. In agricultural industries, they use belt conveyors. In food and beverage industry, they also use belt conveyors. In bottling industry, they use the slot or apron conveyors. In manufacturing industries, so as seen on this picture, they use roller conveyors. In warehouse and logistics, they also use roller conveyors. And in packaging industries, in this picture, they used ball conveyors. So in maintaining a conveyor system, a human-machine interface, or an HMI, allows you to analyze and monitor historical and real-time data from the conveyor system to analyze and monitor the operation of your conveyor system. So also in maintaining a conveyor system, it is also important to do like regular inspections, the monitoring of motors, system audits, and also you need to ensure that you have spares for in stock, or like you need to change over. And then the the operator should also be trained enough on how to run the system, and they should know what to look for when they identify errors or problems. So conveyor system selection factors. First is you need to consider the material being transported, whether the objects you will transport in your conveyor are light or heavy. Second is the environment in which it will be used. Third is the size of the system, its width and length. Fourth is the belting, and lastly is the speed of the conveyor, like how much it needs to accumulate at a time or how long it takes to sort the items. And these are our references. And that is all for the second topic.